right, guys. So last time we were together, I we went through these notes. Those were called. That video was called Atomic Structure Notes. So I just wanted to review a couple things for what we need to learn today to make Bohr models. So this is a basic example, first of all, of a Bohr model, which is not the most perfect model of an atom, but that should be an R is a good one to start with when you are just beginning with atoms. So, what I want to remind you of is that in our electron shells, which these are these circles, each one is called an electron shell. They make up this electron cloud, it's just this whole area where the electrons can be found. The first level can always only hold 2 electrons, and then the second and third level can hold 8 electrons. We know that for an element, we always know the number of protons because that's the atomic number. And so if an atom has 3 protons, it has to be lithium 100% of the time. Okay. If an atom has, I don't know, what's sulfur here? Sulfur 16 protons, it has to be sulfur. Okay. So we know immediately how many protons are in this element. So say we were trying to create lithium. So we know that lithium has 3 protons. And for now, we're also going to assume that, well, let me take a step back. Protons are positive, right? So for our atom to be neutral, what else do we need 3 of? Exactly, we would need 3 electrons to make our atom neutral. Okay? Now, the last thing we need to figure out is the number of neutrons, which are neutral. And if you'll remember, the mass of the atom is mainly found in the nucleus. Okay? The neutrons and the protons. The electrons are almost equal to 0 in mass. Okay? So if you think about it, if we took the mass of an atom, and remember, that's made up of protons and neutrons, right? And we subtracted the number of protons from it, well, then that should just give us the number of neutrons. And that's what we wrote over here. We're going to round the atomic mass, right? That was this weighted average found from all the different isotopes. So we round it, we subtract the number of protons, and we get the number of neutrons. Okay, so if we were doing lithium, 6.9 would round to 7, right? We subtract the number of protons, and it must have 4 neutrons. Okay, so this is lithium that we're talking about. All right, so you're going to be making models online since you weren't able to be here, and so when we also made models in class, just it helps us to have a hands-on connection. So we're going to give 3 protons here to my lithium, and what else goes in the nucleus? The neutrons. So I'm going to give it 4 neutrons, and then here's where it gets really important and that you pay attention to this part. So how many electrons do I need? I need 3. How many can go in that first level? Oops. Do you remember? Only 2. Okay, and so even on this model here, you can even see that they have a spot here in that first energy level. Okay, and but we actually need 3 electrons, so 1 goes in this outer level. Okay, now if I were to draw a model of lithium, it would look like this. So I would have how many protons? So this is literally what I would want it to look like on your paper. 3 protons. Okay, so don't do the circles for me. It's hard to count them. 4 neutrons, because there can get to be a lot of protons and neutrons. So you're going to write 3p for 3 protons, 4 neutrons. This is in the nucleus. So in my first energy level, I'm going to put an electron here at the top. This is going to be our pattern. We're going to start at the top and one at the bottom, because that's all it can hold. And then in our second level, we're also going to start at the top. Okay, so this would be what your drawing of a Bohr model of lithium would look like. Okay, now a couple more things that I need you to know, and they are that electrons, what's the charge on an electron again? They are negative, of course. So you can see that electrons are actually found in pairs. Okay, there are 4 pairs to make up the 8. But since they're negative, do they attract each other or repel? They repel, of course. So they're not going to join each other as a pair until they have to. Okay. So if I'm looking at something that has, for example, a total of 7 electrons, so here we have 2 in our first level, 2, 3, then I'm going to add 1 here, 4, 5, 6. Okay, so I'm going to put 1 in each pair because they don't want to pair up. Okay, but on the 7th electron, it will be forced to pair. So I would put it right here. And then I would just continue on around my circle again. So this would be something that had, what did I say? 7 electrons, 1, 2 in the first level, and then 1, 2, 3, 4, 5 in the second level. Okay, so let's do that one more time. So always the 2 in the first level first, and then as you go, you add, we're going to start at the top. 1, 2, 3, 4, and then if we needed more, 5, 6, 7, and 8. All right, and so that would be the same way that you would draw it. Okay, so you wouldn't ever draw an electron or draw a Bohr model where you had, for example, two, well, obviously never more than 2 in the first level, but you would never draw it where you had like a 2 pair right here and then 1 right here, right? This is wrong. This one, if there were 5 total, then this third one would need to go down here. Okay, then you would add 1 here, so that would be an atom with 6 electrons, and then you would go back around 7, 8, 9, 10 for an atom that had a total of 10 electrons, 2 in its first level and 8 in its second level. Hope that helps.